Alright, good day viewers. Today we'll be looking at equilibrium of forces. It's a continuation of equilibrium of forces, and the topic we'll consider is moment of a force. Moment of a force. We say the moment of a force about a point is the product of the force and the perpendicular distance of its line of action from the point. So moment of a force about a point is the product of the force and the perpendicular distance of its line of action from the point. Now mathematically, the formula for moment of a force is equal to force measured in Newton, times perpendicular distance measured in meters. Okay, so moment is force times perpendicular distance. Now we look at the principle of moment. The principle of moment states that when a body is in equilibrium, the sum of the anticlockwise moment about any point is equal to the sum of the clockwise moment about the same point. Okay, so the sum of the anticlockwise moment about any point is equal to the sum of the clockwise moment about the same point. In addition, the sum of the forces in one direction is equal to the sum of the forces in the opposite direction. That means you can say upward force is equals to downward force. Okay, so that is the principle of moment. It talks about sum of anticlockwise moment is equal to the sum of clockwise moment, and also it also tells us about the sum of the forces in one direction is equal to sum of forces in the opposite direction. Now, one thing you must also note about moment, it says that pivot, the fulcrum, and the balance points all mean the same thing. Pivot, fulcrum, and balance point mean the same thing. It is represented with a small triangle. So that is used to represent the pivot, the fulcrum, and the balance points. Alright, we have a question on the board. It says a body of mass 58 grams is suspended at the 20 centimeter mark of a uniform meter rule. The meter rule is adjusted on a pivot until it settles horizontally at the 40 cm mark. Determine the mass of the meter rule. Quickly, let's solve that question. Now you can say let the mass of the meter rule be m. You can use capital M to represent that. Alright, and the mass is measured in grams. Okay, so the mass of the meter rule is m measured in grams. Alright, then we'll draw the meter rule. Now the total length of a meter rule is 100 cm. Total length of a meter rule is 100 centimeter. Okay, take note of that. Okay, so we'll draw the meter rule and we assume that is our meter rule. Okay, and the total length of this meter rule is 100 centimeter. The total length of the meter rule is 100 cm. Okay, that is total length, which is 100 centimeter. Okay, so take note. And the center of gravity now most times is at the center, so half of 100 is 50. Okay, half of 100 is 50, so it means that my center of gravity will act at the center point. Okay, and this is where the mass of the meter rule is placed. The mass of the meter rule will be placed exactly at the center of gravity, where is G. So if that is the case, now it implies that distance from here to here will be 50 centimeter, and the distance from this point to this point as well is also 50 centimeter. Okay, so I explained that in most cases the center of gravity acts at the center of the meter rule. So if the meter rule is 100 cm, a center of gravity now will be at 50 centimeter mark, and that is where the mass of the meter rule is placed exactly at CG, a center of gravity. Okay, then it goes on to say that a body of mass 58 grams is suspended at the 20 cm mark of a uniform meter rule. So we assume that, and if here is 0, This is the starting point. Perhaps the 20 centimeter mark will be somewhere here. So you place your body there. Distance from here to here is 20 cm. From here to here is 20 centimeter. And I place the body 58 gram exactly at this point. Okay, then I continue. They said the meter rule is adjusted on a pivot until, take note of this, the pivot. I say the pivot is called the fulcrum or the balance point, until it settles horizontally at the 40 cm mark. So the pivot is placed at the 40 centimeter mark. Now we'll check that. Let's look at that quickly. So if from here to here is 40 centimeter will be somewhere here. 40 cm will be somewhere here. You place your pivot at this point. So it implies that distance from here to here now is 40 centimeter. Okay, this is exactly where the pivot is placed. So from here to here is 50. 50 minus 40, this other side will be 10. Okay, that is, if from this distance from here to here, from this point to this point is 50, and from here to here is 40. 50 minus 40, this side will be 10 centimeter. Okay, all right. Okay, so we take note of that. Then if the distance from here to here is 40 and from here to here is 20, this other distance here will be 40 minus 20. You get this side as 20 centimeter. 20 centimeter distance. All right, so take note of that. Then we'll take moment, taking moment in anti-clockwise direction with respect to the pivots, and you also take moment clockwise direction with respect to these pivots. Okay, so you state that anti-clockwise moment is equals to the clockwise moment. So taking moment about the pivots, taking moment about the pivot, you have that this is our pivot. This is the pivot. Okay, you have that anti-clockwise moment will be equal to the clockwise moment. Okay, so the anti-clockwise moment equals to clockwise moment. That is using the principle of moment. Now the anti-clockwise moment now will be this times the perpendicular distance from here to here is 20. Now I told it is force times perpendicular distance. In this case now I'm making use of the mass. That will be this mass times the perpendicular distance. Okay, which is 58 gram multiplied by perpendicular distance from here to here is 20 centimeter. It's equal to, this other one now is the mass mg, the mass m grams multiplied by my perpendicular distance from here to the pivot is 10 cm times 10 centimeter. Okay, so I'm having this 58 gram times 20 equals to m times 10. So if I make m subject of formula, I'll have make m the subject of formula. So making m the subject of formula, I'll have that m will be equals to 58 times 20 divided by 10. Okay, so I divide by the coefficient of m. The coefficient of m is 10. This is the coefficient of m. This is the coefficient of m. M has a coefficient of 10 centimeters. So I divide by the coefficient. M now will be equals to 58 times 20 divided by 10. Alright? So 0, we cancel out 0. We have that m is equals to 58 times 2 will give me, okay, so this will give me 116 gram. So therefore the mass of the meter rule is 116 gram. Okay, and so take note of that. Take note of everything we have solved here. That small triangle is called the pivot. We took anti-clockwise moment equals to clockwise moment with respect to these pivots. Right? So take note of everything that has been done. Observe, so taking moment about the pivot, anti-clockwise moment equals to clockwise moment. We have something like this. Finally, we arrive at the answer 116 gram. Okay. Alright, we have another question on the board. It says, using the diagram below, calculate the moment of the force of 10 Newton about point P. Now this is point P. You see that this other point is point O, and there is a diagonal line. The distance on this diagonal line is 12 meter. Then you have a vertical force 10 Newton, and then a horizontal, and the angle of inclination between this distance 12 meters and the horizontal is 30 degrees. So I explained earlier that this is a diagonal line, and the horizontal, the angle of inclination between the diagonal and this horizontal is 30 degrees. So this 12-meter distance must be resolved to a horizontal distance. We know that moment is force times perpendicular distance, so we must get the perpendicular distance of OP. We say OP, distance OP must be resolved to its perpendicular distance, So if I take that portion out, if I cut it out now, I have something like this. And I have here as 12 meters. This is point O. This is point P. You can call here 90 degrees. Then here is 30 degrees. So the side facing angle 90 is my hypotenuse side. The side facing the angle of inclination is my opposite side. The remaining side becomes my adjacent. And what I'm looking for is the adjacent side. So if, for instance, I call here X. Okay? Now we use the basic trigonometric ratio, and I'll be having, so making use of the basic trig ratio. Okay, now I have, if you observe, I have the hypotenuse side, which is 12, and then I'm looking for the adjacent side. So adjacent of hypotenuse is cos. Okay, so I'll use that. Adjacent of hypotenuse, that cos 30 degrees is equals to the adjacent side over the hypotenuse. So I made use of car. Okay, so cos 30 degrees equals to adjacent of hypotenuse, and my adjacent side there in that diagram, the adjacent is OX, distance OX, over hypotenuse is OP. Hypotenuse is OP. Okay, so this now is distance OX is unknown, as distance OX is unknown, and OP is 12 meters. Okay, so if I cross multiply now, I have that distance OX is equals to 12 cos 30 degrees. Okay, so distance OX now will be equals to 12 times 0.866, which means that by multiplication I'll be having, okay, by multiplication I have 10.392 meters. Alright, so that is distance OX. But if I choose to solve in solid form, you say distance OX, say, or distance OX is equals to 12 cos 30 degrees, and cos 30 in solid form, cos 30 is root 3 over 2. Okay, so this will go here, this will go here is 6. So I'll be having distance OX as 6 root 3 in meters. Right, 6 root 3 in meters. So I've gotten what I want. I can then further ahead with the solving, and I'll have, so I've gotten this distance OX as 6 root 3. That is, this distance is 6 root 3 meters. Okay, so I assume that here is X. So moment is force times perpendicular distance. I will take a perpendicular distance, I take my anti-clockwise moment, taking anti-clockwise moment with respect to point X. Okay, So that will be this force times the perpendicular distance. So take anticlockwise moment with respect to point X, and I'll be having, I say, taking anticlockwise moment of force 10 Newton with respect to point X. So I'll be having 10 Newton times the distance there is 6 root 3 meters. So if I multiply 10 times 6 will give me 60, that is 60 root 3 Newton meters. Final answer 60 root 3 Newton meters. Okay, this is in short form, but then if I choose to solve it the other way around, this is that is, say, or solving the other way around, the moment which is force times perpendicular distance, and the distance is OX. Okay, the force there is 12. The force is 10 rather, 10 Newton. Force is 10 Newton times perpendicular distance OX is 10.392. Okay, so if I multiply that, I'll be having, this will give me 103.92 Newton meter. Okay, so similar to 60 root 3. This is in short form, and then taking it the other way around is to give you this using the decimal. I have 103.92 Newton meter. Okay, so take note of everything we did. Alright, so take note of everything. We had distance OX at 6 root 3. Then took anticlockwise moment of the force about 10 Newton, of force 10 Newton about point X. So I have that. Moment is the force times perpendicular distance. I have 60 root 3 or 103.92 Newton meter. That is it, force times perpendicular distance. Take note. So the distance OP must be resolved to its perpendicular distance. So we resolved it. We took the right angle triangle. So resolving this way, we had 6 root 3. Okay, so take note of everything that was done there. Alright, we have another question on the board. It says, what is the moment of the force F about point P in the diagram below? Okay, so this is the force F, and we're asked to find the moment about point P. So a moment must be force times perpendicular distance. So we have to resolve this P. So quickly, let's do that. Now if I draw this, I have my force F. Okay, that is the force F. And then I'll take this distance to point P. Alright, and here is a theta. Okay, so if I extend this line now, we know that the total angle here, if this is theta, the total angle here is 90 degrees. Okay, total angle is 90 degrees. If this is theta, from here to here is 90. Okay, so that means this remaining angle now, 90 minus theta will be this side, 90 degrees minus theta. Okay, we have this angle as 90 minus theta in degrees. So if here is angle 90 and this smaller one is theta degrees, it implies that this side now will be the whole of this 90 minus this is 90 minus theta. Okay, and so take note of that. So have that at 90 minus theta. So The moment now will be this force times the perpendicular distance. So we'll resolve this way. If I cut out this triangle now, if I cut this triangle out, I'll have something like this. Okay, so here is 90 degrees. That is 90 degrees. And this angle now is 90 minus theta. Right? Okay. So quickly, if this is point P, you can call here point O and call here point Y. Alright, so what I'm looking for is this distance. And then I can then find that out. This side now will be my hypotenuse side. The side facing this angle of inclination is opposite. And here is the adjacent side. Okay, so what I have now is just adjacent and hypotenuse. So I use cos. That is cos 90 minus theta will give me, this is cos 90 minus theta degrees is equals to the adjacent side over the hypotenuse side. And the adjacent side there, remember this is the angle. Okay, the adjacent side there is OY, distance OY, and the hypotenuse side is distance OP, so that would be, okay, so I have that. Then if I make OY subject to formula, I have that that OY, distance OY, equals to cross multiply this times this, that is OP cos 90 minus theta. So I'll cross multiply this, we'll multiply this, and I'll have OP cos 90 minus theta. And then I'll come back again to this diagram. Remember that I said here is point P, so if here is O, that means distance OP is Y. I will indicate it that this side is Y. Distance from here to here, OP is Y. That means the hypotenuse here is Y. Okay, so my hypotenuse is Y. So if here is Y, here is also Y. So I'll take that. Distance OP is Y. It means that distance OY equals to small y cos 90 minus theta. Okay. Now I've gotten this distance. I've gotten distance OY as y cos 90 minus theta. Alright, that's distance OY. That is this distance here, which is y cos 90 minus theta. Alright, so quickly I can then continue taking moment about point Y now to be force. My force here, F times perpendicular distance. Okay, so that is it, the force times the perpendicular distance, this distance. So moment is this force times perpendicular distance, and we go this way, not this one but this other one, perpendicular at 90 degrees. So that is it, to be the force times perpendicular distance. And I'll have, so taking moment about point Y. This is and it's an anti-clockwise moment. I'll be having, the moment is the force times perpendicular distance. So the moment there will be, my force is F. The force is force F. My perpendicular distance is distance OY. It's distance OY, which is equals to F times y cos 90 minus theta. This will give me Fy cos 90 minus theta. That is the moment. The moment of the force is equals to Fy cos 90 minus theta. Final answer. Okay, so this is the final answer. So the moment of the force is Fy cos 90 minus theta. Right? So let's come back again, quickly observe. This was the distance given to us. We had to resolve it to the horizontal axis, that is a perpendicular distance. Okay, and this was how we did the resolution. So I said if here is theta, the full angle 90 degree. Okay, and this other smaller angle now, this other angle at this side will be 90 minus theta. This is 90 minus theta here. Okay, so we extracted this component out. We have a right angle triangle, cut it out, and we had this. So this is 90 minus theta, this is hypotenuse, this is adjacent. When we did the resolution of the force, we had here as y cos 90 minus theta. Y here is y. Alright, that's adjacent to hypotenuse. This is it, using the trig ratio. So we're using car now. We say that cos 90 minus theta will be the adjacent side over hypotenuse. The adjacent side is distance OY, which is this, and the hypotenuse, if you observe, the adjacent is this, then the hypotenuse is y. Adjacent is this side, hypotenuse is y. So distance OY over distance OP, OY over OP. So making OY subject of formula, this will cross multiply this times this, and I have OP cos 90 minus theta. And the value of OP is small y, so I put it there. Observe, this is distance OP. Distance OP is small y. Okay, so this now will be in place of OP, I write small y cos 90 minus theta. We're taking moment about point y. Moment is force times perpendicular distance. That will be F times distance OY, and the value of OY is y cos 90 minus theta. So this will give me Fy cos 90 minus theta. That's my final answer. Alright, we are still on moment of a force, and the next question we have there says a meter rule is found to balance horizontally at the 48 centimeter mark. Let's take that down. Okay, so we know that this is the meter rule. Okay, this is our meter rule, and that the total length of the meter rule, this total length is 100 centimeter. This is the total length of the meter rule is 100 centimeter. Okay, and it's said to balance at the 48 cm mark. That means if this is 100, we can assume here to be 50. We can assume here to be, let's assume that this point is 50. That means 48 centimeter will be very close. 48 will be very close at this point. Okay, so we take this point now as our center of gravity, exactly at the 48 cm mark, CG, center of gravity. That means distance from here to here is 48 centimeter. Okay, this is center of gravity, and I say the mass of the meter will always act at the center of gravity. And let's assume that the mass is m in grams. Okay, to act at the center of gravity. So the meter rule balances at the 48 centimeter mark. That is at the center of gravity. We assume it to be 48 cm from the question. Alright, it says when a body of mass 60 grams is suspended at the 6 cm mark. So it says the body 60 grams is suspended at 6 centimeter mark. So we assume that from here to here is 6 cm. Okay, so we come down here. This distance from this point to this point is 6 centimeter. So we place the body 60 grams here, 60 grams, and the distance from here to here is 6 centimeter. While the distance from this point, okay, to this point is 48 centimeter. That one shows us, this one shows us the center of gravity. Where this is at the center of gravity is exactly where the mass of the meter rule will be placed, at the center of gravity. And then it was at the 48 cm mark. Then the body 60 grams is placed at the 6 centimeter mark. You know, this is the starting point, point 0. Okay, so from 0 to here is 6 centimeter. You place the 60 gram body. Alright. It goes on to say that the balance point is found to be at the 30 centimeter mark. Okay, and you must know that this balance point is the pivot or the fulcrum. So the pivot is found to be at the 30 cm mark. So now we'll locate 30 cm. If from distance from here to here is 48 cm, it means that 30 centimeter will be somewhere at this point. So I call this my pivot, which is the balance point. I assume that distance from here to here is 30 centimeter. Okay, so distance with respect to this pivot from the starting edge from 0 to the pivot, the distance is 30 centimeter. Okay, so this is my pivot. I'm taking that distance as 30 cm. Okay, and then implies if distance from here to here is 48 minus 30, this distance will give me 48 minus 30, that will give me 18 centimeter. Okay, that is from here to here is 48 minus 30, this side will be 18 centimeter. Okay, now let's look at this. If the distance from here to here is 6 cm and distance from here to here is 30 minus 6, I'll be having this distance as 24 centimeter. Okay, so I had here as 30, from here to here is 30, and here to here is 6. So 30 minus 6, I will have here as 24 centimeter. Alright. Okay, so this is it. That show you 100 centimeter, showing you the total length of the meter rule, and then it was found to balance at the 48 cm mark. This is it. At the center of gravity, distance from there to there is 48 centimeter. Then a body 60 gram was placed at 6 centimeter mark. This is the body, 60 gram mass was placed at the 6 centimeter mark. Okay, and then you also observe that the pivot, which is the balance point, is at the 30 centimeter mark. So that is it. So we stated that 48 minus 30 will give you this side as 18, and that 30 minus 6 will give you this smaller side as 24 cm. So the next thing now is to take moments. Taking moments with respect to clockwise moments and anti-clockwise moments. So we are going to take moment with respect to the pivots. Take moment with respect to these pivots. Okay, take moment with respect to the pivots. So taking moment with respect to the pivots. The pivot is the balance point. The balance point. Okay, that would be, say, anti-clockwise moment using the principle of moments. Anti-clockwise moment is equal to the clockwise moment. So I say anti-clockwise moment equals to clockwise moment, and the anti-clockwise moment there is this force times the perpendicular distance. That will be 60 gram times perpendicular distance is 24 times 24 centimeter is equal to, okay, this other one, m gram times 18 centimeter times 18 centimeter distance. Okay, that is this one times perpendicular distance 18 cm, and this times perpendicular distance 24 cm. So we are taking moment with respect to these pivots. So if you observe clearly, the distance between this force and the pivot is 24 cm. So it will now be this force times the perpendicular distance, and distance between this other force, the mass there, and the pivot is this distance 18 centimeter. So it will be this force times the perpendicular distance, that is force times perpendicular distance with respect to the pivot, and force times the perpendicular distance with respect to this pivot. Okay, so I will make m the subject of formula. If I divide by the coefficient of m here is 18, so I'll have that m is equals to 60 times 24 divided by 18, and I'll be having this. Okay, now this will give me, if I multiply 60 times 24, okay, so if I multiply, I'll have 1440 divided by 18, and this will give me 80, that gives me 80 gram. Okay, so this is the mass of the meter rule. The mass of the meter rule is 80 gram. Alright, says that therefore the mass of the meter rule is M equals to 80 grams. Alright, that is it. We have solved and we arrived at 80 grams as the mass. Okay, then we'll move over to the next question there. Next question says the distance of the balance point from the zero end if the body were moved to the 13 centimeter mark. So let's look at that. Let's look at that quickly. Okay, now let's assume that this is our meter rule, and remember that this was at the place where the mass of the meter rule was placed. Mass of the meter rule was placed exactly at 48 cm mark. It was placed exactly at the 48 centimeter mark. This was where the mass of the meter rule was placed, and we call this our center of gravity. And then we obtain that mass of the meter rule. We obtain the mass of the meter rule as 80 grams. Alright? And then we are told that we should find the distance of the balance point from the zero end. Now, distance of the balance point from the zero end, if we assume that this is the balance point from the zero end, this is the zero end. Now, the distance, now we can use any alphabet to represent that distance. You can say let the distance be y. So if we call that distance y, distance of this balance point from the zero end is y. Now, if the body were moved to the 13 cm mark, now a body was pushed to the 13 centimeter mark. So this is 13 centimeter from the zero end. You have this, and remember that that body, the body we are considering here is 60 grams. The body is 60 grams. Okay, that is this particular body, 60 grams. Previously the body was at the 6 centimeter mark. Okay, but then it was adjusted to the 13 cm mark. So we adjusted this body to the 13 centimeter mark to be at this point. So now we take the 60 grams and adjust it to the 13 centimeter, 13 cm mark. If the body were moved to the 13 cm mark, so assume that from here to here is 13 cm, and that is my 60 gram mass. The 60 gram mass was adjusted to the 13 cm mark. Okay, so if distance from here to here is y, and distance from here to here is 13, it then means that this smaller distance now, from here to here, will be y minus 13. Okay, that means y minus 13. You get this? And distance from here to here is 48. Then from here to here is y. 48 minus y will give us this distance. So I have here as 48 minus y. Okay, so if from here to here is 48, here to here is y. 48 minus y will be this side. Then I will then take clockwise, anti-clockwise moment, and I'll take what? Clockwise moment. You take anti-clockwise moment with respect to the pivot, and clockwise moment with respect to this pivot. Okay, and that will give me, so you take anti-clockwise moment with respect to the pivot and clockwise moment with respect to this pivot, and I'll have, you say, taking moment with respect, taking moment with respect to the pivot, taking moment with respect to the pivot, I will have anti-clockwise moment equal to clockwise moment. Clockwise moment equals to clockwise moment. Alright? And the anti-clockwise moment there will be this force times perpendicular distance. That is 60 times y minus 13. So this now will be 60 times y minus 13 equal to, the clockwise moment will be this 80 times y minus 8. That is with respect to the pivot. Is this times the perpendicular distance. Okay? That is 80 times 48 minus y. Okay, take note. Clockwise moment is this 60 times this distance, and 80 times 48 minus y with respect to the pivot. Okay, and 60 times y will give me 60y. 60 times minus 13 will give me, that will give me minus 780, is equals to 80 times 48 will give me, that will give me 3840 minus 80 times y gives me 80y. Alright, so I'll carry this over here, then take this one here. So this is 60y plus 80y is equals to 3840 plus 780. Alright, so 60 plus 80 will give me, this is 140y, is equal to 3840 plus 780. This will give me 4620. I'll divide by the coefficient of y, which is 140. So y will be equals to 4620 divided by 140. This will eliminate this, and I will finally arrive at, I will have, this will be equals to 33 centimeter mark. So therefore, the balance point or the pivot was adjusted to the 33 centimeter mark. Okay, so observe how we solve that. We're taking moment with respect to the pivot. Anti-clockwise moment equals to clockwise moment, and we had 60 times y minus 18 minus 13 equals to 80 times 48 minus y. And when we cross multiply, when I open the bracket by means of expansion, 60 times y is 60y, 60 times minus 13 is minus 780, 80 times 48 is 3840, 80 times minus y is minus 80y. I had to collect like terms. I take this minus 80y over here, it will change to plus 80y. Take minus 780 over to this place, it changes to plus 780. 3840 plus 780 gives me 4620, and 60y plus 80y gives me 140y. Okay, so y now divide by the coefficient of y, divide by 140. I have that y is equals to 4620 divided by 140, that is 33 centimeter. So it means that the balance point was adjusted to the 33 cm mark. That is the value of y. Okay, so I have the value of y. I have the value of y here. Y is 33 centimeter. That's the balance point, and that is the second diagram. Okay, take note of that. Okay, so we have solved that question. All right, let's move over to the next question quickly. Let's move over to the next question. All right, we have another question on the board. It says determine the magnitude of P in the diagram above. Okay, this is the diagram. You see that force P is inclined at an angle 30 degrees to the horizontal. It is a diagonal force. Okay, on this diagonal line, then it is inclined at 30 degrees to the horizontal. The force on this block, or the weight of the block, is 40 Newton, acting vertically downwards. Distance between this block and this pivot is 20 centimeter, and the distance between the diagonal force P and the block is 30 cm. So that means we have to find the distance between this force P and the pivot. That will be 20 plus 30, which is 50 centimeter. Okay, so let's determine the magnitude of P in the diagram above. Quickly, we'll draw the free body diagram, and we'll have to resolve this force to both vertical and horizontal axis. And I'll be having this. So I have something like this. This is the force P, inclined at 30 degrees to the horizontal. So I'll resolve it vertically. I'll resolve this force vertically. Resolving it vertically, I'll have P sine 30 degrees, and then I'll resolve it horizontally. Resolving it horizontally, I'll have P cos 30 degrees. Okay, so I've explained how you can get that. Now the next one you look at is the weight of this block, the weight which will act vertically downwards, the weight which is 40 Newton, 40 Newton weight acting vertically downwards, and distance between the weight and this other point is 30 centimeter. 30 centimeter. And then this is the pivot, which is the balance point, and distance from this pivot to this other point is 20 centimeter. 20 cm. It then means that the total distance there from here to here now will be 20 plus 30, which is 50. I have 50 cm. 50 centimeter distance. Okay. Alright, so we will then taking moments with respect to this pivot. Okay, so quickly let me explain how I got p sine 30 and p cos 30. You know, if I take this portion out, if I extract that portion out, I have something like this. First p, here is 30 degrees, and then the side facing here is hypotenuse. Then this will be my opposite because it is facing the angle of inclination, and here will be my adjacent. So this is px and this is py. Okay, so let's find that quickly. So I'll use, let's look for cos. Cos 30 degrees there will be the adjacent side over hypotenuse. The adjacent side is px, hypotenuse is p. So making p a subject of formula now, I have that px will be equals to p cos 30 degrees. That was how I got this. P cos 30 degrees. Okay, then look for sine. Sine 30 degrees is equals to the opposite side divided by the hypotenuse. Okay, and the opposite there is py. The hypotenuse is p. So if I make py subject of formula, cross multiply this will multiply this, and the first py will be equals to p sine 30 degrees. P sine 30 degrees. So that is py. So I've gotten py as p sine 30 degrees. Okay, so that was how I got this as p sine 30, and I got the horizontal component as p cos 30. Just doing the simple resolution of forces, I got this and I got this one, horizontal and vertical. Okay, so the next thing we do now is to take moment of the force. Now this one will go in a clockwise direction. This force will go clockwise direction with respect to the pivot, and this other one will go anti-clockwise direction with respect to this. Now you see that this one does not have any perpendicular force. So since this is horizontal, it is lying on the same plane with the rule or with the beam. Okay, so on this ruler here, you see that this force is lying exactly on the same axis with this ruler. So it does not have any perpendicular force, because normally for a horizontal force, its perpendicular distance must be vertical. So there is no vertical distance there. So since it is lying on the same direction with my ruler, I will neglect this force, neglect this p cos 30. Okay, so taking moment with respect to the pivot, I'll have something like this. So taking moment with respect to the pivot. Okay, with respect to the pivot now, I'm having a clockwise moment is equals to anti-clockwise moment. Okay, so that will be the clockwise moment here is this times this distance, which is 40 Newton force, times my perpendicular distance is 20 centimeter, 20 cm, and the anti-clockwise moment will be this times the perpendicular distance, the distance from here to here. That is taking moment with respect to this pivot. The distance from here to here is 50. That will be p sine 30. P sine 30 degrees. P sine 30 degrees times this times my distance 50 cm. times 50 centimeter. Alright, and then this now will be 40 times 20 equals to P sine 30 is 0.5 times 50. Okay, so 40 times 20 will give me 800, and then P times 0.5 will be 0.5 P times 50. Okay, so 0.5 times 50 will give me 25. This is 25P equals to 800. I'm making P a subject of formula. P will be equals to 800 divided by 25, and this will finally give me, so when I divide this, I'll finally arrive at 32 Newton. Okay, 32 Newton. So we have obtained the value of force P. I've gotten the value of force P. So therefore force P is 32 newtons. Alright, so that is it. We observe how we took clockwise moment with respect to the pivot, and the anti-clockwise moment to go like this with respect to the pivot, and this is distance with respect to this, and the distance of this force to the pivot is 20 centimeter. Alright, so take notes. Finally we get our answer as P equals to 32 Newton. Alright.